Warm greetings to everybody. I'm Dr. Francina Shalini, Associate Professor, PG and Research Department of Mathematics, Nirmala College for Women, Coimbatore. In this learning model, we are going to see about the Fibonacci sequence and the golden ratio and a small relationship between the Fibonacci sequence and the golden ratio. First, let us see about the person Fibonacci. And he is the person Fibonacci, the famous mathematician. And he lived, his real name is Leonardo Pisano Bogolo. He lived between 1170 and 1250 in Italy. And this Fibonacci it is not his real name, it's his nickname, which means son of Bonacci. He is not only a great mathematician who invented the Fibonacci sequence, but he is a famous person who helped to spread the numbers 0, 1, 2, 3 throughout Europe in replacing Roman numerals, which we know 1, 2, and 3, 4, etc. And now we go on to the Fibonacci number. The Fibonacci number is nothing but a sequence of numbers which is determined by combining two integers before it. These are the numbers which are also called as the nature's universal rule or nature's secret code. Now we will see how we calculate or how we find the Fibonacci number. So 0 plus 1 is 1, 1 plus 1 is 2. Like as I told earlier, it is nothing but the addition of two numbers before. So it is 2 plus 1, 3. It goes on and on like this. Now the Fibonacci sequence. We know sequence is nothing but the sequence of numbers, which is a series of numbers written with commas. And here this sequence is nothing but the Fibonacci sequence, which has a rule which we just now saw, that is 1 plus 0 plus 1, 1, 1 plus 1 is 2, 2 plus 3, 5, and goes on and on. It has the same pattern goes throughout. Now, there's an interesting fact about this Fibonacci sequence. What is the interesting fact is this sequence goes on like if we see the sequence, it's a first an even number 0, then it is an odd and odd number 1, 1, again an even number 2, and then again two odd numbers 3 and 5, again an even number 8, and two odd numbers 13, 21, and it goes on in the same fashion. So when we add two odd numbers, we always get an even number, but when we add an even or odd number in any fashion, it gives an odd number. So we just saw Fibonacci number in mathematics. Now let me tell you about something more interesting, how Fibonacci number is used in nature. That is Fibonacci petals. We have a beautiful flowers here to tell us that these flowers represent the Fibonacci number. Now the first flower is a flower white calla lily, which has one petal. Again the next second the pretty flower with the pink color is the two petal flower euphorbia. Now here comes a Fibonacci number. 2 plus 1 is 3. 3 petal flower is the trillium, and three petals plus two petals together is the five petal beautiful flower, which is called as the columbine. And it goes on and on. From these beautiful pictures which is present here, we as mathematicians, we will be knowing only about the daisies and the sunflower has got here 55 petals, and daisy has got 89 petals. And this is how Fibonacci number is not only used for mathematics but also is used in nature in these beautiful flowers. Now again, another important interesting fact of the Fibonacci number is the Fibonacci spiral. Here this diagram represents the Fibonacci spiral. This Fibonacci spiral is nothing but we make squares with these length. That is, if we see 5 plus 8 is 13, again 13 forms a square which neatly fits together inside. So for instance, it adds up together 13 plus 21, 34, and we just draw a beautiful spiral, which we call it as the Fibonacci spiral, which is each one is in the form of a square. Now, in the above slides, we just saw about the Fibonacci sequence, how Fibonacci numbers are used in petals, this Fibonacci spiral. Now we are going to see about the golden ratio. The golden ratio is nothing but it's a symbol denoted by pi, and it is like the Fibonacci sequence which we saw earlier. Golden ratio is also used in geometry, not only for mathematics but also for art, architecture, and in many other areas. And it is also called as the golden section, golden mean, golden number, divine proportion, divine section, and golden proposition. So what is this golden ratio definition? It is nothing but the ratio is equal to the ratio of the sum of larger two quantities. to be very simple, it is nothing but the ratio of two quantities, which is written as a by b is equal to a plus b by a, which is equal to pi. As I said earlier, pi is the representation of the golden ratio. Now here we see this clear representation, that is, we divide a line into two parts, that is, the whole length is divided by the long part and is also equal to the long part divided by the short part, that is a by b is equal to a plus b by a, which is 5. Now here, to be even more clear and crisp, the explanation is given here. A by b is 5, a plus b by a is 5. We write it, when we solve that, we get 5 is nothing but the golden ratio, which is 1 plus 1 by 5. Here it is given even more clear. So a by b is equal to a by a plus b by a. 5 is equal to 1 plus 1 by 5. And to be test that the digit of accuracy, if we substitute 5 to be 1.618, it is 1 plus 1 by 5, it is again 1.61805. So the actual value of the golden ratio is nothing but 1.61803398887. It keeps on going. It has no pattern, specific pattern. Now golden ratio, as I told earlier, is used in various fields. Now we see in plants like sunflower, the spiral, aloe vera, it is here the golden ratio and the golden spiral, which is seen here, Fibonacci spiral. The animals, it is seen in the shell. In our human face also is in golden ratio. It is in golden ratio. And in art, it is the Mona Lisa picture, the Last Supper. In architecture, it is the Great Pyramid of Gaza, the Parthenon, are all examples of the golden ratio. Now, what is the relation between the Fibonacci sequence to the golden ratio? That is, a by b is equal to a plus b by a, which is given clearly, the larger length, which is divided by the smaller length, which is equal to 5, that is equal to 1.618. So what is the relation is, if we take two successive terms in the Fibonacci sequence, the ratio is very close to the golden ratio. So if we take a bigger pair of Fibonacci number, the approximation will also be close to the golden ratio. So it's very clearly depicted in this representation. Now we know the Fibonacci sequence. We just now learnt it earlier. It is nothing but 1, 1, 2, 3, 5, 8, 13, 21. It goes on and on. Now I divide. 1 by 1 is 1. 2 by 1 is 2. 3 by 2. 5 by 3, which is approximately 1.67. Likewise here see 8 by 5, 1.6. 13 by 8, 1.625, 21 by 13, 34 by 21, which is approximately 1.6190. So the golden ratio is approximately equal to 1.618. So now the interesting fact is phi is also equal to 2 into sine 54. So the Fibonacci sequence, the ratio is very close to the value 1.618, and the golden ratio is an irrational number, which is the solution of the quadratic equation x squared minus x minus 1 equal to 0. So now we have come to the conclusion. We saw what is the Fibonacci number, Fibonacci sequence, Fibonacci spiral, Fibonacci in nature, golden ratio, the relationship between these two. And now what is the conclusion of this module is, see, Fibonacci sequence and golden ratio has got various applications for all the professionals. It's an excellent example of how mathematics is used everywhere in all diverse regions of study. And again, the golden Fibonacci sequence and golden ratio has got a deeper appreciation through everywhere, the world around us, with new ideas and discoveries. Those pictures gave us a clear idea of how it is used in art, architecture, everywhere. Finally, in this module, who sees this module, whether we are a mathematician, artist, a financial analyst, of whoever we may be, but the Fibonacci sequence and the golden ratio is a fascinating and a valuable concept to explore. So thank you for your patient listening. I hope this module was very interesting and useful to everybody. Thank you.